Welcome back to Topic 8 for Algebra 2, Graphing Linear Equations. In this video, we're going to learn how to graph on a coordinate plane, as well as learn how to graph on a graphing calculator or on Desmos.com. First, let's start on learning how to graph on a coordinate plane. We're going to convert our equation to slope-intercept form, y equals mx plus b, if necessary. Now, this is optional, I should say. You can also graph in point-slope form or in standard form. However, I think it's personally easiest to graph in slope-intercept form, because as it states in number 2, you're going to identify the slope and the y-intercept, first plotting that y-intercept using the form 0, b, so it lands on that y-axis. Since the y-intercept, it must land on the y-axis. And then from that y-intercept, you're going to count off using the slope, either rising or falling, or then running left or right. Then you can connect all of your points, and voila, you've created a line. So let's start off with some examples. In our first example here, we have y equals 6/5 x plus 5. Our y-intercept here is positive 5, so we're going to start on our graph at over 0, up 5. So our point 0, 5. Now our slope is 6/5 here. So this is a positive slope, so we can count up 6 and to the right 5, and our line would go somewhere along over here. However, it would go off of our coordinate grid here. So we can extend our line in the other direction. Positive 6/5 for our slope is the same thing as negative 6 divided by negative 5. Remember, a negative divided by negative is a positive. So instead of going up 6, we can go down 6, and then to the left 5. Now that we have our point, we can connect it with our other, and then draw our line. Moving into our second example here, we have 2x plus 4y equals 8. Now this is in standard form. If you would like, you can use the shortcut in order to determine the slope and the y-intercept. Or you can do it the quote-unquote long way and convert it to slope-intercept form. So in this case, in order to convert it to slope-intercept form, we want to isolate that y. So what we would do first is, this is a positive 2x, subtract it from both sides. Now this would give us 4y equals 8 minus 2x. Now this is a positive 8, and in order for it to look more like slope-intercept form, what I like to do is swap the order of these, keeping the operation that's to the left of it alongside it. So we get negative 2x plus 8, just so we have that x term first. Then we can divide everything by 4. Make sure you divide every single term by 4, and we get y equals negative 2/4 is the same thing as negative 1/2. X plus 8 divided by 4 gives us 2. So now we can graph this. Our y-intercept is at positive 2, and our slope here is negative 1/2. So we're going to go down 1 to the right 2, down 1 to the right 2, down 1 to the right 2, etc., etc. Now our negative could also be swapped to the bottom, so this could be rewritten as y equals 1 over negative 2x plus 2. So we could also rise 1 and then go to the left 2. See how it's extending our line in the opposite direction. Once we have all of our points, we can connect our dots, somewhat at least, and make our line. Moving into our next example, we have x equals negative 2. Now we don't see a y variable in this at all. We only see an x variable. So if we think about when x equals negative 2, it's at this point, but because it doesn't specify our y variable, or the y value, our y value is going to be all of these values, giving us a vertical line. X equals is always a vertical line. It's kind of the opposite of what students tend to think. What I like to phrase it as is, since it's x equals, it's going to cross the x-axis at whatever point that is. Similarly, we can look at the other line, or the other example. We have y equals 4. So at positive 4, since it doesn't specify an x value, it's going to be all of our x values. It's going to cross our y-axis at 4. and give us a horizontal line. Now moving on to the next part, we can use a graphing calculator. Graphing calculator is really helpful, especially as you progress in your mathematical career, to get comfortable with graphing equations. In this video, we're just going to specify graphing linear equations, but as you move forward, especially in Algebra 2, we'll get into more polynomials, quadratics, rational functions, things such as that. So the basic steps for graphing on a graphing calculator, you're going to input your equation into the y equals button. It's in the top left-hand corner. And then you're going to hit graph, which is in the top right-hand corner. After you see your graph, you might need to adjust the window size. So that's kind of the viewing size to make sure if it's too zoomed in or if it's too zoomed out so you can accurately see your graph. You can see the table of values by pushing second and then graph. And then if you want to get kind of a standard 10 by 10 view of the graph, you can hit zoom 6, which is also known as Z standard. However, if you don't have a graphing calculator handy, what you could do is you can use Desmos.com. Desmos has a lot of great tools, including some activities. But what I tend to use is the graphing calculator, especially in scenarios such as this. So in Desmos, what you can do is you can type in your equation, and what I notice is that this specifically works in order to do this kind of tool when your equation is in slope-intercept form. Then what you're going to do is you're going to click the gear button. It's in the left side of your screen, the top left. And then from that, you're going to click the table icon. And that will give you a table of values. So again, you can use this with your graphing calculator, or you can use it with Desmos.com. So we're going to have a few examples here. And there is a window side part of these examples, our viewing window, where I ask you to kind of write what are your values that you have for your minimum and maximum. If you're using Desmos.com, you will not need to use that. You would honestly just zoom in and out using the plus or minus button provided on your screen. So in our example here, we're going to go one by one and see what these look like on Desmos and fill in a table of values. Our first example, we have y equals 2x plus 1. Our slope is the m value right next to the x, which is 2, and our y-intercept is positive 1. So we can go over to Desmos.com and type it in. So we have y equals 2x plus 1. Now here we have our graph. Again, if you want to zoom in and out, you can use the positive or the negative button. And then in order to see your table of values, you can do one of two things. If you click the plus, you can add a table, your own table, if you would like to create a table for a table of points to create your function or equation. Or what you can do, like I said before, is click on the gear and then click on your table here. Now it will give you a table of values for this specific line. So what we're going to do now is we're going to go over back to our problem and write this table of values down. So here we have the table of values of -2, -3, -1, -1, 0, 1, 1, 3, and 2, 5. If you are using a graphing calculator, feel free to look at the viewing window and write down what values you had in these respective labels. Our next example, we have y equals 1/3 x plus 12. So our slope here is 1/3. Our y-intercept is 12 and is already in slope-intercept form. We can go back to Desmos, and I like to erase them in between just so it's a little less confusing. We get y equals 1/3 x plus 12. And notice here how we do not see our graph. That's because we need to zoom out a little bit, and there it is. So we hit our gear, hit our table, and there we go. Here we have -2 and 11 1/3, -1, 11 2/3. 0 gives us 12, 1 gives us 12 1/3, and 2 gives us 12 2/3. So again, there's your table of values. With example 3, notice how this is not in slope-intercept form, so we need to convert it first. So we can subtract 3x from both sides. And we get 5y equals -3x minus 2. Again, having that slope first, it's just easier. Divide everything by 5. And we get y equals -3/5 x minus 2/5. Our slope here is -3/5 x. I'm sorry, -3/5. And our y-intercept is -2/5. Don't include the x with your slope. It is not a slope, it is an x-coordinate. We can go back to Desmos, type it in, get our table of values. So here we have y equals -3/5 x minus 2/5. And we have our graph right here. Hit the table icon. There we go. Our points are -2.8, or 8/10 I should say, -1 2/10, 0 -4/10, 1 -1, and 2 -1 6/10. Let's try one other example. We have 2x minus 4y equals 22. 22. So we have, if we subtract 2x on both sides, we get -4y equals -2x plus 22. Divide everything by -4, oops. And we end up with y equals -2 over -4 is +1/2, x minus 11/2. So our slope is 1/2, and our y-intercept is -11/2. We can type that in. And here we go. So we have -2, -6 and 5/10, -1, -6, 0, -5.5, 1, -5, 2, -4.5. And there we go. Now, last but not least, I want to look at a word problem. Here we have corporate profits in billions of dollars can be modeled by the equation y equals 400 plus 40x, where x is the years from 1990. We're asked to analyze the graph of the equation to answer the following questions. So we have the graph provided on the right. Now parts A and B all deal with the scale if you're using a graphing calculator. Since we do not have the application provided here, we're just going to skip to part C. However, if you do have a graphing calculator, the settings that I had that were helpful were 0, 12, and 1 for the x, and then 0, 1000, and 200. We can kind of look at it on our graph as well. So on the x scale, we're going by ones, jumping from 1 to 2 to 3 to 4, etc., etc. and our min is 0, and then our max is 12. Or if we go look on our y-axis, we go from 0 to 1,000, and our y-scale is going by 200s. Okay, so what were the corporate profits in 1990? Again, this is kind of starting at year 0. So since we start at 1990, this is year 0. If we look at our graph, this is at 400. So the corporate profits were $400. Now we want to look, when do those profits double? What year is that? So double of 400 is 800. We're going to look at our graph, find where it matches up with our line. That's right here. So that is 10 years after 1990, which would give us the year of 2000. And that was topic 8 for Algebra 2 on graphing linear equations in a coordinate plane and also on a graphing calculator /desmos.com. Thanks for watching.